The fully armored cab, weighing over 2 tons,
Hidden within this sprawling industrial complex lies the birthplace of modern artillery dominance.
This is where raw steel is transformed into the high-mobility artillery rocket system, known as HIMARS.
The process begins with military-grade titanium and reinforced steel plating, designed to withstand immense pressure. Precision lasers cut the chassis components with microscopic accuracy, ensuring every part fits perfectly.
Every sheet of armor is inspected before it moves to the welding stations.
Certified master welders fuse the chassis frame. This skeleton must support 5 tons of rocketry. For the longest seams, automated robotics take over to ensure structural consistency impossible for human hands.
Imperfections are ground away. The surface must be flawless for the anti-corrosion coating.
At Station 4, the chassis begins to look like a vehicle. The main rails are bolted together.
Quality control is rigorous. A single millimeter of deviation halts the entire line.
Once the frame is approved, it moves to the drivetrain installation sector.
Lower it slow!
The heartbeat of the HIMARS, a 6.6-liter diesel engine delivering massive torque.
The skeleton is complete. Now, it needs a brain.
While the chassis is built for mobility, the cabin is built for survival. This is the Armored Crew Citadel.
Layers of ballistic steel and composite materials are bolted into the frame, rated to stop small arms fire and shrapnel. The windows are 3-inch thick ballistic glass, offering the same protection as the steel walls, without compromising visibility.
Easy now!
The fully armored cab, weighing over 2 tons, is mated to the chassis.
Before the electronics go in, soundproofing and thermal insulation line the interior to protect the crew from the rocket's roar.
The nervous system of the HIMARS consists of 4 miles of military-grade wiring.
Each connection is waterproof and shielded against electromagnetic interference. The dashboard is not for comfort. It is a control center.
This computer is the brain. It calculates ballistics, wind speed, and trajectory in milliseconds.
Touchscreen interfaces replace the analog dials of the past, allowing rapid targeting updates.
The first power-up. Systems check. Green lights across the board.
Blast attenuating seats are installed to absorb the shock wave of a mine explosion from below. The crew compartment is sealed and secure.
But a truck is just a truck without its weapon. Next, we build the launcher. Meanwhile, in the heavy fabrication wing, the cage takes shape. This structure must hold 6 rockets or 1 massive missile.
The launch rails are machined to within a micron of tolerance. Friction during launch could be catastrophic.
These hydraulic pistons are the muscles. They must lift the fully loaded pod in seconds, even on a steep slope.
The rotator base allows the HIMARS to spin 360 degrees, firing in any direction, regardless of where the truck is parked.
Down, down, down!
Flexible armored conduits carry power and data to the rockets. They must survive thousands of rotations without cracking. The moment of integration. The weapon system meets the vehicle.
4 massive bolts secure the launcher to the chassis. That's all that holds the violence in place. Before it can serve, it must be protected. The vehicle enters the paint facility.
Chemical agent resistant coating, or CARC, is applied. It resists corrosion and decontamination chemicals. The camouflage pattern isn't random. It's a specific NATO standard designed to break up the vehicle's silhouette.
Baked at 140 degrees, the coating hardens into a shell tougher than standard automotive paint.
The HIMARS is built and painted. But can it fight? It's time for the proving grounds.
Out on the proving grounds, the HIMAR is unleashed. It must prove it can handle rough terrain at 60 miles per hour.
The all-wheel drive system fights for traction. Reliability in mud, snow, and sand is non-negotiable.
Unlike older systems, the HIMARS loads itself. No extra crane vehicle is needed.
A crew of 3 can reload a full pod in under 5 minutes.
Range is hot. Clear to fire. Final inspection complete. The vehicle moves to the firing point. Target coordinates locked. Calculating trajectory. Three, 2, 1.
A standard GMLRS rocket accelerates to Mach 2.5 in seconds.
Precision delivery. Accuracy within 1 meter.
Test successful. This system is combat ready.
From raw steel to the front lines, this is how modern warfare is engineered. End of process.
Come on, get up there! Get back there! Yalla, move along now. Steady, steady, watch your.
Align that one flush with the edge, and we need to keep the stack straight.